All right, hello again. This is Jeff Scott of Blackhawk Technical College. I've been going over the PowerPoint slides for chapters 1 through 11, and I've done the first 7, for the Starting Out with Java from Control Structures through Objects 6th edition textbook by Tony Gaddis. And speaking of textbooks, this is the book we will use for the 152-143 Intro to Java Programming class for the spring 26 semester at Blackhawk Technical College. So in Chapter 8, a second look at classes and objects, we'll talk about static class members, passing objects as arguments to methods, returning objects from methods, the toString method, writing our own equals method, and methods that copy objects. This is probably where the book starts to get a little bit more complex. Okay. We'll also discuss aggregation, the reference variable, enumerated types, garbage collection, even though I already have, and class collaboration. Every time you create an object, and remember an object is an instance of a class, each object has its own copy of instance variables. Earlier we declared a rectangle class, and then we made a couple of rectangle class objects. They were box 1 and box 2. And box 1 and box 2 each had their own length and each had their own width. Okay? So as mentioned, instance variables require that an instance of a class be created. All right? But there are also what are known as static fields. Believe it or not, you've already seen these, and there's a good example shown on the screen right here. Java has a built-in math class. So I can say double val equal math.sqrt 25.0. A couple things. First of all, the number that's in here has to be a double, so this has to be a double. And second, it's math.square root. I don't have to create an instance of the math class. It already exists. All right, that is a static method right there that I'm calling. All right, so static methods in static fields do not belong to a single instance of a class. Rather, they can be shared. I mentioned before, when you think static, think one. So class fields are defined using the static keyword. So look at it this way. I used to, let's suppose that we're going to write a program. And what we want to do is we want to be able to create a lot of these different rectangle objects. All right, so instead of instance count, I'm going to call this private static int, and I'm going to call it rectangle count. If I don't put the word static in there, and now I go and I create a bunch of rectangles inside of a loop, all right? And if I don't use static there, or let's just say I go and I create one rectangle. Then a little later I create another rectangle. Then a little later I create another rectangle. If I don't use static here, if I use instance count without static, what's going to happen is each time I come back into that routine, the field is initialized to 0, but it'll get reinitialized to 0. So the idea is by making something static, it's going to hold its value between calls. It's the difference between this. All right, if I create 100 different rectangles, do I want 100 different counters, each with a value of 1, or do I want one counter with a value of 100? If I want that, one counter with a value of 100, I make it static. All right. There's an example of this in the book. We'll go over that later, so I'm not going to do that right now. Again, methods can also be declared static. And guess what? You've already done this. Main has always been a static method. When a class creates a static method, you don't have to create an instance of that class in order to be able to use it. So we've got public static double miles to kilometers. So we can create this without having to create an actual instance of the class to use the method. All right? And if that doesn't make a lot of sense, you have to work with it for a while. The bottom line is this. So far, in this chapter, we're continuing our move away from creating everything inside of main. And once you start, main really should be typically in a Java program, main will be in a file by itself. That'll be your demo. That'll be static. All of the other methods that you use will be in their own file, and that'll be in the class file. Some of those methods that either are created in there or that are referenced in there may be static methods, which means that they can be used on their own. As mentioned here, typically you use static methods to create utility classes. The math class, which is built into the Java library, is an example. Static methods must and only can communicate with static fields. If you try to have a static method communicate with an instance field, a non-static field, you're going to get an error message. All right. We mentioned this before in earlier chapters that when you pass an entire object, such as an array of bank accounts, they get passed by reference. Java passes all arguments by value, all right, but that's for primitives. When you pass an object to a method, what ends up being passed is the address. So the copy is not passed, a pointer to the object is passed. So any changes you make will be permanent changes. You can also return an entire object from a method. Again, methods, it's only one thing, so it's only one object, but it can be one object with multiple different parts to it. All right. So far, when we've used the toString method in here, we have used it literally. In other words, we've just converted something to a string. If we do this right here, if we say stock this equals new stock, print this out, XYZ company dot toString, you might be in for a surprise. What you're going to get is an address of where XYZ company lives in memory. So if you actually want to print stuff out, what you have to do is override the toString method. So as it says, all objects have a toString method that returns the class name and basically where the address of it is in memory. You typically would want to override that default method and put your own method in there. All right. The equal, we've talked about this before, but I want to show a similar example to one I've shown you earlier, and that is this. If I come through here and I say string name1 equals Jeff. String name, should have been name1, name2 equals Jeff. If I attempt to do this, if I say if name1 equal name2, that is going to be false. Because what that says is, does name1 and name2 point to the same areas in memory? And it does not. This is false. What I want to do here is to say if name1 dot equals name2. So that's how you check two strings for equality. So that will come back as true. Now I'll leave that up there for a second just so you can see it. All right, so don't do this with strings. Do this with strings. All right. You can use equal methods with a lot of different things. Again, it says if you do that with classes, only the addresses of the objects are compared. That's what I just showed you. But you can write your own equal method that goes through and it compares every single element that's in a class with every single other element. And that's typically how it's done. All right. Most of the rest of the stuff in this chapter, we're going to go over it. We're only halfway through. But this is really heavy stuff. There's two ways to copy an object. It says you can't use simple assignment. You can do a reference only, where you copy the address of one to another, and that's called a shallow copy. Or you can do a deep copy, where you copy every value from one to the other, and we'll look at examples of that when we get to the book part of the class. You can create a copy constructor. And again, we'll look at that stuff when we get to the stuff in the book. It makes much more sense to do that. All right. With aggregation, that's when one class has a reference to another class inside of it. So let's say, for example, that I create a class that's called clock. and I put in for clock hours, minutes, seconds, etc. All right, set time, get time. All right, now I create another class that's called alarm clock. So I've got a clock class, and now I want to create an alarm clock. And it's going to have the same kind of things, hours, minutes, seconds, set time, get time, but it'll have a few other things, set alarm, etc. So rather than going back after I've already got a clock class and creating a new alarm clock class and repeating stuff, I could say that one of the elements in the alarm clock class was a clock class. That's an aggregation. All right, so an alarm clock has a clock as part of its component. And we will look at this instructor textbook course and demo that they show right here. We'll look at this in a lot of depth and breadth of coverage when we get to that area when we go over it actually just in the book. You should be able to look at this now and know, again, name of the class, name of the instance variables, minus means in all of these, the minus means what? They're private. Then the name of all the methods. You'll notice that for each one, the first method, course, so that's the constructor, instructor, so there's an overloaded constructor, and textbook, so there's an overloaded constructor. And again, all of our methods got to have a plus in front of them, meaning what? Meaning they're public. All right, a few things here. It says avoid returning references to private data elements. Return references to private variables will allow any object that receives the reference to modify the variable. What they're saying here is be careful. There's a thing that's discussed in security terms that's called the principle of least privilege. And what that means is only give something the abilities that it needs to get the job done and nothing more. And that's pretty much what they're saying right here. All right, null reference. As it says, a null reference is a reference variable that points to nothing. If a reference is null, you can't do anything with it. The this we already talked about. So remember, if we have an instance variable defined up here someplace that says int feet, and we want to use the same name in here, we need to say this dot feet. In the line of code that we have right here, if we leave off the this dot, all it's going to do is take that copy, and it's going to copy that copy to itself, not to the instance variable. You can use the this reference as it says there to call a constructor from another constructor. A little confusing. And you can also create enumerated data types. An enumerated data type is a developer creating his or her own data type. So we've got a new data type here called day. Its values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. All right? And then I can declare a variable of that type. So day, workday. So workday is of type day, which means it can only hold these values. So I can say day workday equals day dot, and again, after I say the day dot, it's one of these things that must come in here. And the way that this is set up automatically by the system is Sunday is given an integer value of 0, so that's 0, 1, 2, 3, 4, 5, and 6. If I want Sunday, if I want that to have a value of 1, because that's the first day, now Sunday's got a value of 1, Monday is 2, Tuesday is 3, Wednesday is 4, Thursday is 5, Friday is 6, and Saturday is 7, if I wanted to do that. So an enumeration is a new specialized data class that you create. What it can lead to is code that is much more self-documenting. Different things that you can do with enumerated data types. You can run toString on it. You can use equals, compare to, and we'll look at the examples that are shown in the book when we get to that point. Where enumerated data types can really shine are used inside of switch statements, again, for making your code much more self-documenting. All right, garbage collection. When objects are no longer needed, they should be destroyed, which frees up memory that could be used for other purposes. Java handles memory operations for you. If you set a reference to null, Java will run the garbage collector on it. I've already mentioned the garbage collector to you. As mentioned, it's a process that runs in background. It's under the control of the operating system. Its goal is to reclaim memory from an object that no longer has anything pointing to it. Typically, if you want to force that to happen again, you set the object equal to null. All right. We talked about a constructor method earlier, and that's a method that automatically gets called when you initialize or create a brand new object. Java also has something called a finalize method. Notice as it says, Java will call the finalize method just prior to garbage collection. All right. Some people like to use a finalize method, and what they try to put in there is any housekeeping operation. So if they've got a database open, they'll close it. If they've got a file open, they'll close it. Not only does Java have a constructor and a finalize, it also has a destructor method. But it's used so often that it's almost never even discussed. All right. The finalize is a little bit better, but like the destructor method, you can't determine exactly when finalize will actually run, and that's why it's not used all that often. All right. This chapter ends with talking about class collaboration, which is how two classes interact with one another. All right. So if, for instance, they say that if we design a class called stock purchase, it would probably collaborate with a class that's called stock that we previously defined. So we come up with ways like this, and we create these. This is called a CRC card. A class's responsibilities and collaborations card. It's just literally an index card where you put the name of the class up here and things that the class is responsible for knowing and things that in the class that is responsible for doing. So how it's going to communicate with other things. And that's pretty much it for this chapter. All right.